So I will go ahead and make my apology now for having some marketing slides here at the beginning. But I think it's important to put in context what we do, who we sell to, and these types of things as far as our solutions go, because that's very important to what we do as a company. So we'll try to avoid as much of that as we can. So what we call Lustre at DDN is Exascaler. It's our productized packaged solution we've been selling for quite a number of years, about a decade now. So we have a lot of experience in the market. We have lots of customers around the world. We'll talk about some of those to build the solutions that we require, that you require as customers. Some of our key customers that we have sold to, deployed over the years, lots of universities, people like NOAA, NASA. These have been relationships that we've developed, like I said, over a decade. We continue to support these solutions in the field. Places like Titech, all around the world, so really large installations. So we have a really large field organization, people spread around the world, so that we have different perspectives, different customer inputs. People like Sanger, life sciences, different application sets that typically would be thought about within the Lustre community. The DDN solution itself is built around our hardware platform, as it has been for a number of years. Our solution has about 1 million lines of code dedicated to the storage fusion architecture operating system, as we call it. That is a lot of work over the years, basically solving the problems that we've seen with all parallel file systems in general, as well as our other systems that we work through. We're really focused on getting performance from the system, so maximum performance is really a key for us. Enterprise management caching system, those are things that those are things that we really pay a lot of attention to, because in reality, one of the keys to doing this type of business is that, you know, the benchmarking conversation yesterday touched on this. It's really good to run and have a big number. Those things are very impressive, but at the end of the day, no one really runs at that level of performance all the time. So you have to have a system that's sustainable, is able to ride through failures, and is able to sustain a real workload performance. So we've really focused on that a lot. Direct Protect is a technology we've built. We'll talk about that some as we go through the solution set here. Plug and play Lustre. We have embedded solutions. We have solutions that are built on external servers. We deploy both. Basically, the solutions that we embed can be installed very quickly. They're factory installed, come to your site. We plug the drives in, spin the machine up, and it's online and running very quickly. So in those types of applications, it is you know, it's a really large feat to have a system that comes up and runs at those types of speeds in a very small amount of time. From a support perspective, we've been doing Lustre support for a number of years. We have a true level 1, 2, and 3 support model. We have our own engineers. We have our own field support folks, as well as WAM Cloud as our level 3 support backing, which we'll talk about a little more. The other big investment that we've made over the years is in tools. It's very important to be able to quantify what the system's doing, to be able to look at the issues that are coming up, try to extract data when you have large sites like many of you do. Having tools to do that with are very important. So we have a scriptable API that allows you to run commands across the entire array of systems, pull data back from those. As announced yesterday by Robert Reed, we've already embraced Chroma, so we will be shipping that in the near future. And our roadmap for even more robust management, we have a plan for the next 12 months to introduce even more tools to make the management of the system more easily done. From the perspective of our support, as I said, we have true level 1, 2, and 3. WAM Cloud, we feel very comfortable with our partnership there. As you've seen over the last several days, WAM Cloud is the leader as far as deployment, development of the ongoing Lustre development. So we have a direct connection with them. I think we're WAM Cloud's biggest customer at this point, selling support services. So that's a key for us, that we're very important. We're a leader in the Lustre market. As I said, we've been deploying Lustre systems for about 10 years at many of your sites. Many of you have been deploying solutions on our equipment for many years, doing your own support. So we have a very flexible model. One of the key things I think that's important to bring up from our perspective is that many people view Lustre as just a pure HPC play, that it only is usable in the large lab environments, and that's not true. We've sold Lustre into many environments. When you look at the types of deployments we have in life sciences, research, energy, and commercial spaces, it's very impressive. There are a lot of people around the world that are using Lustre in other types of organizations, so you really have to focus on those and try to cater solutions to them, because there are workloads out there that Lustre really benefits in other markets. So we've been very successful there over the years as well. The third day, I'm kind of the victim of SARP covering some of this data a couple of days ago. Oakridge is very kind with sharing their data. So we have several other sites that are larger and faster at this point, but they're not so easy about sharing their data. So we'll review a couple of things with Oakridge. Obviously, when you look at Jaguar, very complex, very large system. It's been in production for about 3 years now. A lot of components. I don't think SARP touched on this, but there's 48 9900 controllers there, 13,000 drives, so it's a really large configuration that's been in production for this amount of time. He did touch on this fact that the support of the machine has been incredible. For 8 out of the last 11 months, it was up at 100% of the time, and it's 99.26% uptime over the entire 2011 span. So a file system of that size is very good. It shows the stability of Lustre. It shows the capabilities that have been built into that. That doesn't mean that you haven't had failures, you haven't had issues. That means that the system is configured properly, has lots of HA capabilities, and that it is able to sustain and ride through those types of events as they come up. So what do we see when we have support issues? So DDN has a wide variety of customers that rely on us for their Lustre support. So the things that we see a lot of, encountering known bugs. Since Lustre is very stable, we have a lot of customers that don't want to upgrade, right? If it's not broke, don't fix it. So they will be running a version of Lustre that may be several cycles old, and that causes some problems occasionally because they will call in and have hit a bug that someone's fixed in the past year or two. So we certainly do see that. We get a lot of general questions, things people want to see. How do you use this new feature? How do you add this type of capability? How does this work? The other thing as far as that goes is people change workloads. A lot of you work in academia, and a key part of that is that you get new users all the time. And when that happens, your workloads change, your application sets change. Many of you use hundreds of different applications, and after some period of time, you may notice that there's a change in your performance model. Things just don't seem as you would expect. So we get lots of calls, people asking questions about how to set their systems up appropriately for things that have changed since the initial installation. Probably the largest one that we see is based around performance. People, as I said, their applications change, lots of different things over time that can be affected. So one of the key pieces of knowledge that we have is with our field engineers that many of you know, we have the ability to, you have to look at your network, your actual file system, the underlying storage, because it's very difficult to determine sometimes what the source of the problem is. And if you just look at it from a Lustre perspective, you're probably going to miss the boat a lot of the time. Many of the problems that we deal with that are characterized as Lustre performance issues actually may not be Lustre performance issues. They may be some other, it could be an SFP and a switch somewhere. So it takes a lot of knowledge, it takes a lot of capabilities, and having folks that understand the entire solution to be able to deliver these types of requirements. The other component there is that we've developed tools over a number of years to look at slow disk, look at the performance of the system. The sizes of the IOs that are coming in are very important to getting good performance. Once you get an issue like that, you go back and you troubleshoot SRP, things like that. When you don't get when you're not getting full performance, you're getting IOs that are broken and so forth. So we've dealt with that a lot over the years. And the last component is that you do hit a new bug occasionally. We have a number of people on the team that are here, Ahara, some of those folks, Sven, that do testing on new releases. They've been doing a lot of Lustre 2X release testing, and you do log new bugs against those kinds of things and early adopters as well. So how do we work through these types of issues? That's kind of the key. I don't want to spend too much time on this part of it, but developing tools for performance analysis is key. Drive failures are a big problem. We'll talk about that. focus on MTDL. That's a big thing because MTBF in the past has been a kind of a key. You know, you see it in a lot of RFPs. People want to know what the MTBF is, but in reality, with these large file systems, what matters is the mean time to data loss, because you want to make sure that you can certainly maintain your data at any cost. Performance without compromise. One of the big things that we see at scale is how you try to manage these types of issues when you have a slow drive that causes your entire file system to be slow, those types of things. And Amdahl's law. So basically, your lowest common denominator is going to dictate the performance of your system. So if you have a system with slow components spread across it, you're going to be running at that slower level all the time. So this is an example of a large system, you know, a 10 petaflop type of system with a 1 terabyte per second target type of performance model. Kind of a swag here at 3% annual failure rate on drives, so that gives you 1.2 drive failures per day. So it shows you how important at really large scales. It kind of blows out of proportion for most people's sites because most people don't have a site with 15,000 drives installed, but it shows you how important this can be over time. Without performance protection, striped I/O will only run as fast as the slowest LUN. So that's important because in a really large system like this, you're always going to have rebuilds going on. So if you're really limited to the size or the performance of the slowest common denominator, you're going to be in bad shape. You're never going to achieve top performance. So in this example, with a 60% full file system, an SFA system being compared to a MD RAID type based system, you're looking at rebuild speeds of 40 megabytes a second versus 25. The mean time to rebuild is virtually the same. We rebuild all blocks. The software side would rebuild just the data. The key issue here is the performance impact. We only would suffer about a 10% impact because of the architecture that we have, and you'll see up to a 63% impact on software RAID because of all the contention and so forth that's built into the system. Based on those numbers, you would end up being able to sustain out of that terabyte per second, 820 gigabytes per second on a solution built off of DDN equipment versus 455 gigabytes per second off of a software RAID-based system. So how do we do that? Basically, the system itself allows you to, the architecture itself is built around not having data chain. Everything is point-to-point type of architecture, so you're able to sustain really high I/O performance on the back end. You're able to lose 20% of your back end channels and still maintain performance and be able to maintain your data integrity as well. We really have a really over-provisioned back end, so you have 60 gigabytes per second worth of back end bandwidth. That allows us to be able to get really fast rebuilds and sustain performance through rebuilds, so that's a really big key for us. So a couple of key points here. You know, we've had parity protection on reads for many years now. It's been a problem on SATA drives. So we've offered that type of protection since the 9550 days, so probably 6 or 7 years ago. One of the things that was touched on yesterday is T10 diff, and we haven't implemented T10 diff at this point. One of the challenges over the years has been that T10 diff has been around, but applications don't support it, file systems don't support it. Now some people are coming around to it. SATA drives weren't able to support it because they were 512 byte sectors, and you need a 520 byte sector to utilize that. So we developed software a number of years ago, because you can't wait for all these things to come around, that allow you to have a T10 diff-like protection on the system. So that allows you to avoid a lot of the service-related problems when you basically just get an error message that say, okay, I found a data error, I've corrected it and moved on, versus having an issue where you would have actually lost your data. You have background parity scrubbing types of applications, so you check for bad blocks and so forth, make sure your system is stable, so you don't hit those bad blocks in production. In cache protection we talked about. One of the other things that's important when analyzing these systems, when you look at the data that we have gained from customers and so forth, Lustre is geared to be a really large I/O, large throughput type file system. In reality, most of the I/Os that you see are small, from journal updates and you know, just the workloads not being clean in the really mixed environment. So what that leads you to is that you must have a really efficient caching model in order to be successful there. I think Oakridge and some other folks have done some other studies, and I think, if I remember correctly, their average IO size was something like 256K, even at the really, really large scale that they operate at. So it's a real problem being able to actually do this. So it's really a key component. You know, I think Charlie mentioned this a while ago. When you're looking at the tunings that you have to do, it takes a while to work through those and cater those to your actual workload. Those are some of the things that we've done over the years and have a really good feel for how to actually set the system up so you avoid problems, you avoid issues with different types of performance and so forth. So basically, kind of in a summary, the object of all of our lives here is to try to avoid interrupts, to try to have a system that is up and as fast as possible all the time. Build a scalable system that supports many interfaces. Start small, as low as 2 gigabytes per second, and go all the way to 40 gigabytes per second in a single building block. We're developing turnkey appliances. That's been touched on by several people through the days here. That's a key for all of us moving forward. That people want to be able to have a turnkey solution. Everyone's not an expert in this environment, so being able to lean on someone else to provide that expertise is what we're here for. Have a sustainable performance, be able to protect your investment, and basically have good performance with when you do sustain failures on the back end. That's it.
Questions for Keith? Thank you, Keith Miller.
Thank you.